All right, let's continue on with example 5. So here I have a position function given, and you know that one derivative is the position gives me velocity, two derivatives of position gives me acceleration. So first thing I'm going to do is rewrite. So I see this 4 cosine of t over 3 is the same as saying 4/3 times cosine of t. So taking the derivative of 4/3 times cosine, 4/3 is a constant, carry it along. Derivative of cosine is negative sine. And you know the derivative of a constant 5 is 0. And then that's the velocity. And then to take the derivative of the velocity gives me acceleration. So taking one more derivative gives me negative 4/3 cosine. All right, example 6. So here's my function. I want to find horizontal tangent. So that's the same thing as saying find the x's. Find those x values where the derivative equals 0. So I see product rule. So first d second, derivative of cosine is negative sine, plus second d first, derivative of e to the x is e to the x. Setting it equal to 0, I'm going to factor an e to the x out. So I know that e to the x never equals 0, but I know this equaling 0 gives me this. So when does that happen? Pi over 4 and 7 pi over 4. 5 pi over 4. And, all x values. So I know I can go to pi over 4 and add pi, and so that's what I'm going to say plus k pi. All right, example 7, taking the derivative to find the slope of the tangent line, and I can use this to find the exact slope at that exact point. So the derivative of x is 1. The derivative of tangent is secant squared. So plugging in pi, I get secant squared of pi, so that gives me a positive 1. So I get a slope of 2. So now I want to find out what the y value is for this x value of pi. So I plug it in, and I know tangent of pi is 0, so I get pi for the y value. So the xy point is pi, and so I put together the equation of the tangent line. All right, so this says find the fifth derivative. So this little parenthesis of the number above, that's the way of saying the fifth derivative. So first off, I'm going to say start by rewriting the function. And let's take one derivative, two derivatives, three derivatives, and then the fourth derivative is the original function. So this is the fourth derivative. This will always happen if we start with the function of sine or cosine. So if I'm trying to find the fifth derivative, that's going to be this one right here. So that's cosine. So we see with sine or cosine, every fourth derivative comes back to the beginning. So if I want to find the 31st derivative, I don't want you to go and find 31 derivatives. Start by writing the original function. Find the derivatives. The fourth derivative is your original function. So then you've got options of how to find it, what the 31st derivative is. You could think of all the multiples that are inside of 31. So I know that 32 is a multiple of 4. So this would be the 32nd derivative here, right? So if that's the 32nd derivative, then 1 before would be the 31st derivative, so that would be negative cosine. You could also think of the numbers, the number 28 is a multiple of 4. So if this was the 28th derivative, then 29, 30, 31. Get to the same answer of negative cosine. All right, let's just finish up this last one, example 10 here. So this is a little different. So here's my function, g of x, which is f times cosine. So if I'm going to find the derivative, I see there's going to be a product rule. So f of x is first, derivative of cosine, negative sine, plus cosine, derivative of f is f prime of x. All right, so now I'm going to evaluate at pi over 3. So that means everywhere there's an x, I'm putting in pi over 3. So I'm just going to write it in for one step. Then I'm going to use what I'm given. So f of pi over 3 is 4. I know sine of pi over 3 is root 3 over 2. Cosine of pi over 3 is 1/2. f prime of pi over 3, they tell me, is negative 2. So put these together, and that is not negative 7. Oops, so what do I get? So I get, from here, I get negative 2 root 3 minus a 1. All right, let's stop there.